Okay, so I put in a couple little things here. Things that I want you to keep in mind. Okay, these are right-hand rectangles. Sometimes those can get confusing on whether you're using the right or the left. And remember that you go, when you use a right-hand rectangle, that you skip to the first interval. Okay, and then you actually draw to the left. Okay, so, but the side of, it's the right-hand side of the rectangle that's on the function. Okay, I want you to notice that the function is increasing, and that this is going to give us an overestimate of the area. Okay, or sometimes we call it an over approximation. But we're just doing the real basics right now, and it looks like, well, that's a pretty ridiculous approximation, but just kind of go with it for right now. And again, I want you to think about, how are we going to find the area? Okay, so when I want to find the area, I got to go the length of the interval, because it's a rectangle. I'm just going to go length times height, right? So the length was 1. Now, how could we find this exact height? I mean, we could try to approximate it, but what if I said, well, I know that this is x squared, and if x is 1, 1 squared is 1. Okay, so then I'm going to add the second one. Now, the second one also has a width of 1. Now, it's important that you're keeping in mind what the width is, because they're not always equal width. And that's important to know. Okay, so it's got a width of 1. This is 2. So that height right there has to be 2 squared. So kind of keep in mind that I'm taking the length of the interval and then I'm evaluating the function at that spot. Okay, the next interval has a length of 1. This 3 up here is 3 squared. That's 9. And the last one, oops. Okay, so I have 1 plus 4 plus 9. Oops, that should be 16 over there because it's 4 squared. And just as a reminder, because it's going to come up, when we add a bunch of things together, remember that we use that symbol right there for adding. Okay, so it looks like that the area under the curve y equals x squared from 0 to 4 is approximately, and I guess I should put approximately 30 square units. Now again, we know it's something less than that because we can easily tell that we have over approximated it. Okay, well then let's do the same thing, but this time use 4 left-hand rectangles. Okay, so you're going to get out the same thing here. Now, the rectangle is going to be on the left. So I want you to really think about it. We're going to start here. Well, this one has no area right there. Okay, so now my next one's going to go here, and it's on the left. Okay, my next one, I go up, it's on the left. Okay, and then the next one, I go up. Okay, so again, I want you to draw those in, and it seems kind of weird because the other one had 4 rectangles, this one has 3, but it's all going to work out here. Okay, so let me see, where did I put my magic rectangle that I already colored? Oh my goodness. I know, if my head weren't attached, I wouldn't be able to find it. Okay. So again, I want you to make note that on this one we're using left-hand rectangles. Okay, also notice that the function is increasing. And we can see by looking at this, this is going to be an underestimate or under approximation. And run out of room. Okay, so on this first one, it's 1 wide, but the height is 0. Okay, the second one, it's 1 wide. Now its height goes right here. 1 squared is 1. This one's 1 wide. The height is right there, which is 2 squared, which is 4. And then this last one, it's 1, and the height is up here, 3 squared, 9. Okay, so we have 0 plus 1 plus 4 plus 9, and we're going to get that the area is approximately 14 square units. Okay, so again, we know that this is an underestimate, so we know the true area is somewhere between 30 and 14. So can we just go in the middle? Doesn't quite work that way because it's not a linear function. And if it were a linear function, it would be much different. Okay, so well then, is there another way we could make these rectangles? Of course there is. So let's look at the same thing. This time we're going to use midpoint, 4 midpoint rectangles. Okay, so you're going to have the same graph. This time what you're going to do is you're going to look at the midpoint. So in between 0 and 1 is a half. You can put a point there, and then the rectangle is going to go right through that point. Okay, right here, there's the midpoint. And remember, I'm finding the midpoint between here. So I'm looking between 2 and 3. The midpoint would be at 2.5. See if I get that light out of the way. Okay, so at 2.5, I come up until it hits the function. Okay, so same thing here. Here at 3.5, I'm going to come up until it hits the function. Now, I have seen some students just leave it like this. Don't do that, okay? We're doing rectangles, so draw in those rectangles, okay? Don't draw in the rectangles. You'll lose some points there. Okay, so this is going to magically look like this. Okay. So let's notice that these are midpoint rectangles. And when we're dealing with midpoint rectangles, we're not going to worry right now about whether the function's increasing or decreasing or anything like that. Okay, we're only going to be worried about if we have the left hand or the right hand side. Okay, so same thing. This is 1 wide. The height of it, well, now it's a half squared times a fourth. The next rectangle is 1 wide. This is 1.5, which is 3 halves. 3 halves squared is 9/4. Okay, the third rectangle is 1 wide, but the height is at 2.5, so that's 5 halves squared. And remember, I'm squaring because the equation is y equals x squared. And the last one is between 3 and 4, so 3.5, which is 9 halves. 9 halves squared. It is 9 halves, right? No, wait. 3.5 is 7 halves, which is 49/4 right there. Okay. Now there's kind of some things that you're going to see when we're adding these up, that sometimes there's like a nice little shortcut. We could say, oh, I could pull out the fourth from all of these, and then I would have 1 plus 9 plus 25 plus 49. Let's see, that's 50, 75, 84. 4 goes into 84 21 times. So notice that, let's see, was that right in the middle of those two? We had 14 and 30. 7, not quite, right in the middle. So we got to watch out for that. Okay, last one of these guys. What if I said I want you to use 8 right-hand rectangles? Okay, so we're going to do the same thing that we've been doing, but this time we're going from 0 to 4, and this is going to be important. How do you know how wide to make these? Well, if I'm going from 0 to 4, they each have to be a half long, so I'm going to have one here, okay, and then it wants right-hand rectangles, so I go to the right-hand side. Okay, so on this one, it would go there. Then I've got one here. Okay, so I'm just going through and notice that the right hand side of each rectangle is on the graph. Okay, and you're gonna keep on doing that. You're gonna get something a little magical that looks like this. So even though we still have an overestimate, it looks a little bit better than it did on the other one, because the overestimate isn't going to be quite as big. Okay, we could go through all of this, but I'm going to tell you that we end up getting that the area is approximately 25.5 square units. So again, we know that's an overestimate, and we know that's an underestimate, or no, we don't know if that's an underestimate or not, but we're getting a little bit closer. So we're going to see that there's a thing about how many rectangles that we have affecting how good our approximation is going to be. Like, what if eventually I said, well, I want you to make 25 rectangles? What if I want you to make 100 rectangles? What if I wanted you to make the width of the rectangles head towards 0, so they're infinitesimally small, and you have infinite rectangles under there? Aha, that's going to give us a really good approximation. Okay, the part 3 is going to have vocabulary. Vocab is going to be important, so come back for that exciting video.